Another quick look at transformations. So if you have x squared, and then you put a 1/4 in front of it, and you put a negative sign in front of it, each of these does a different thing to the function. Starts out being a normal parabola like that. Maybe a little skinnier than that. Normal parabola more like that. The 1/4 is a vertical stretch factor. Because it's smaller than 1, you could call it a compression. Or if you just say stretch, that works for anything. By a factor of 1/4, meaning the function is flatter than it used to be. 1/4 would make it look more like this. It's a big, wide, more bowl-shaped parabola. The negative sign flips it upside down, produces a reflection. Now, unfortunately, there's a lot of ways to say this. You can say it's a vertical reflection, that it's a top-to-bottom reflection, that it's a reflection across the x-axis, as if the x-axis were a mirror and you were seeing the reflection in it. Either way, your curve will now look like this. It'll still be wide and flat like before, only now, instead of opening up, the curve opens down. Here, this is a kind of wonky way to write this. This decimal is, this fraction is bothering me with the denominator of 3. I'm going to fix that by multiplying the left side by 3 and the right side by 3. So I get y equals, this is more like it. So now that we have y isolated, we can see that we've got a +6 inside the function. That will produce a translation of 6 units to the left, and we have a vertical stretch or vertical expansion by a factor of 3. So vertical expansion. Again, I always say expansion or compression, but stretch is also okay. By a factor of 3. And then we're translated. You can say moved or shifted, but most of the time you'll hear translated. 6 units. Which way? If it's x plus 6, does that move us to the left or to the right? The way I remember it, +6 sounds like it should be to the right, but horizontals are always backwards, so it's left. You may have another mental schema for that. Anyway, if this is your original curve, vertical expansion by a factor of 3 means it's much skinnier than before. It's going to look more like this. It goes up 3 times more quickly. And then we move it 6 units left. So 1, 2, 3, 4, 5, 6. There's our new vertex. And here's our skinny parabola sitting on its new vertex. Of course, with steady hands and a nice piece of graph paper, you could do a much better sketch than this. But if you can do this or visualize this without doing any calculations, that's what we want. We want you to be able to quickly glance at this and say, okay, 6 units left, tall and skinny. Or for this one, wide and flat, only a quarter as high as normal, and upside down.